It was being conducted for two reasons. Firstly, Macmillan feared that the publication of Penny's report would ruin public confidence in nuclear power. More importantly, however, it would jeopardise Britain's nuclear relationship with the United States. In the years since the war, the Americans had been reluctant to share atomic secrets with the British. Macmillan had been trying desperately to persuade the Americans to reverse this position. If they learned about the technical embarrassment of Windscale, Macmillan feared that any chance of nuclear collaboration would be out of the window. Macmillan ultimately decided to address the Windscale accident via a parliamentary white paper that contained an amended version of Penny's original report. These amendments presented a different interpretation of the accident.
The accident was due partly to faults of judgment by the operating staff, these faults of judgment being themselves attributable to weaknesses of organisation.
The blame was being shifted from faulty infrastructure and dangerous processes to operator error. For those who had risked their lives fighting the fire at Windscale, this official condemnation was a kick in the teeth. One physicist described it as absolutely disgraceful, blaming junior people who had no means of defending themselves. Despite some pushback from plant workers, Macmillan's white paper successfully hushed up the major technical problems that had existed at Windscale. On November 8, 1957, a month after the accident, the British tested their first hydrogen bomb in the Indian Ocean. It was constructed from plutonium and tritium produced in the Windscale reactors. The following year, the US-UK Mutual Defence Agreement was signed, which promised cooperation on the uses of atomic energy between the two countries. From Macmillan's perspective, the entire operation had been a success, but this did not alter the reality of Windscale's radioactive fallout. It was estimated that 12 kilos of uranium had been released from the chimney of Unit 1 during the accident. These emissions included large amounts of radioactive isotopes like xenon-135, iodine-131, and cesium-137. Despite assertions at the time that northeasterly winds had blown this material harmlessly out to sea, the truth was more complicated. The wind had indeed been moving towards the Irish Sea between the 10th and 12th of October, but its direction was reversed at higher altitudes, pushing radioactive particles back across large parts of the English coast. Even the material that did follow a northeasterly path did not disappear altogether. Instead, it moved across the Irish Sea, passing over the Isle of Man and onto Ireland. The Windscale accident had very real health consequences. These were most pronounced in plant workers. 14 operators had been exposed to levels of radiation that exceeded the annual permissible dosage. Some, like Arthur Wilson, the man who peered into the viewing hatch of the reactor, were permanently disabled by the dosage they received. Others, like Deputy Manager Tom Toohey, who lived into his 90s, maintained that they had never been affected by their exposure to radiation. The wider impact of Windscale on public health is complex and difficult to gauge. A report published in 1960 concluded that the effects would be negligible,